Again, if I were taking an exam question, I saw this problem over here, I'd probably play around with it first. And let me just look at the integrand first, all right? And the first thing I'd probably do, and this is x here, this is 1 plus cosine x. I'd probably do this first. And what do you get there? Let's write that down. You get 1 minus cosine x quantity squared on top. That's not so bad. On bottom, what do you get? You're going to get, let's see, 1 minus cosine squared x. All right? And, you know, it's not that bad to look at. What do I get over here? I'm going to expand the top out. I'll talk about the key later, by the way. 1 minus 2 cosine x plus cosine squared x. All right, that's not so bad. What do you get in bottom? Well, the 1 minus cosine squared is going to be sine squared. All right, I'm going to keep looking at it and see what else I can do. And put the dx down over here. I'm going to say things are looking like they get much worse. I'm not saying totally bad, but if I had to look at it, I'm going to say they're getting worse. So I'm going to say, you know, maybe that's not the best approach. Then I kind of look around for identities that I know about. And let me write down a few for you that sort of look like this over here. All right? So I'm going to write this over here, that the cosine of 2 theta is equal to, well, I could write that down as 2 cosine squared theta minus 1. I could also write this thing down as 1 minus 2 sine squared theta. All right? And that's cosine 2 theta, by the way. All right? So let me, you know, it's still not looking exactly like I want it to look, but it's getting a little bit warmer. And I'm going to take this first guy here and write down cosine of 2 theta plus 1 is 2 cosine squared theta. There's a reason I'm using theta, not x, by the way. I'll go back to that later. And I'm going to take this guy and rewrite this guy as, let's see, I'm going to write it as 1 minus cosine of 2 theta is equal to 2 sine squared theta. I think I see something here now. I'll write this one over here. And I'll outline what I'm looking at. I'm looking at this, and I'm looking at this. And what would that equal to? Well, it's not. You know, the x in that case is really it's two theta. So I got to write this down now. So it's going to be 2 sine squared x over 2. This is dx over here. Look at the bottom. And the bottom looks sort of like this. And what would that look like now? 2 cosine squared x over 2. Well, I'm getting a little bit better. And what do I see over here? I see sine over cosine. Let me just make sure I'm seeing that. I can get a tangent now. Tangent squared, that is. I'm going to write the tangent in terms of secants. And that's going to be secant squared x over 2 minus 1 dx. And I can do the integration now. And what are you going to get? Got to be careful because you got that argument's x over 2, right? So it's going to be the tangent of x over 2. But when you differentiate that, you certainly get secant squared x over 2, but then you get a half. I got to get rid of the half by multiplying by 2. Minus the antiderivative of 1 is just simply x plus some constant of integration. All right, let's look at the key. This is the key. Did I get that answer? I did. We're good to go in the next question. Thank you.